Let's talk about the chemistry of the Northern Lights. This is a picture of the Northern Lights, or Aurora Borealis, that I took from just outside my house last night. The Northern Lights is something people will travel from all over the world to try and see, and it really is just chemistry that they're witnessing. The chemistry behind the Northern Lights is actually something that you learn in advanced earth chemistry. It's just not specifically taught to you within this context. But drawing these parallels can really help you when you're answering any open-ended or using your knowledge of chemistry questions in your SQA exam. So let's talk about how the Northern Lights actually come about. It starts off with highly charged ions in the atmosphere colliding with molecules of gases like oxygen. And when the highly charged ions and molecules collide, there's a transfer of energy. When the energy is transferred or absorbed by the molecules, what happens is the electrons get promoted up to higher energy levels. These electrons won't stay in the higher energy levels for long though, so they eventually fall back down, and when they do, they emit certain photons of energy. Those quantum of energy that get released correspond to different colours or wavelengths of light. Depending on what wavelength of light is emitted, between 380 and 750 nanometers, you will get a certain colour. So the red part of the Aurora Borealis is to do with wavelengths of light between 750 and 605 nanometers being emitted when the electrons fall back down to lower energy levels. And the green light we see being emitted is wavelengths of light between 500 and 560 nanometers being given off when the electrons fall back down to the lower energy levels. So in short, the Aurora Borealis occur because of highly charged ions colliding into molecules of gas in the atmosphere, promoting their electrons when that energy is absorbed, and then eventually the electrons fall back down to the lower energy levels again, emitting specific quantums of light that correspond to the wavelengths of red and green light. So if you get an open-ended question on the Northern Lights in your advanced hard chemistry paper this year, it's complete fluke. I didn't know that was going to happen, but at least then you might know what to write about now.